Here's another example of the log and exponential graphs. This time bringing in a bit of absolute value as well. We're going to do example 11 from the textbook once again. So we did example 10, now here's example 11. Notice we have the video link. If you click that, you will go to it. Just click the eye over there and you have the actual video of that example 11. Let's continue with this one anyway. Now we have ln of the absolute value of x minus 2. Now remember, with absolute value, the best thing is always to keep the definition in mind, which you'll see I do. So let's go on to the first one. We have to write down the equation of the vertical asymptote. So, well, f is undefined at ln of 0. So we need ln of 0. So x minus 2 must be equal to 0. So that gives x equal to 2. Let's have a look at B. Now we have to go into it, and I'll remind you of the absolute value at this stage. Now we have to find the vertical asymptote and the intercepts with the axes. So, definition of absolute value of A. What is the definition? It's A if A is greater than or equal to 0, and negative A if A is less than 0. What this is really doing is saying, well, absolute value of A is left as A if A is positive or 0. We attach the 0 to this one just by definition. It could have been attached to the lower one. In fact, it doesn't matter. But the absolute value of A, if A is less than 0, if A is negative, its sign is changed to make it positive again. So therefore, the absolute value of x minus 2 there, I'm only looking at what we're taking the log of, is equal to that by definition. Notice the same thing, the contents of the absolute value, if the contents are greater than or equal to 0, and the change of sign of the contents if the contents are less than 0. So, f of x equals. Now we're just going to do exactly the same thing where we're going to bring in the ln. So there we are, ln of x minus 2, if x minus 2 is greater than or equal to 0. And ln of 2 minus x, if x minus 2 is less than 0. So we have two graphs as such. Y-intercepts, f of 0. Now remember that this is what we're going to use now for substitution of that. In fact, f of 0, well, there we are, we substituted into there. Ln of negative 2 is undefined, so that can't be the case. And ln of 2, if x is less than 0. So in fact, it's 0.7. Well, I'm doing substituting 2 in, so I have ln of 2, and now we have that. 0.7 found on your calculator, and that becomes 0.7. So that can go onto the axis as well. Let's put this in here. What x-intercept? Ln of absolute value of x minus 2 equals 0. Now remember, the thing is to change to exponential form if it's lns, if we can't go any further there. So we're going to go absolute value of x minus 2 is e to the 0. Base e, so therefore base e. And that's equal to 1. Now a quick way to do it, I'm not sure if you've done that way, but if you have an absolute value equation, once you've isolated the absolute value on one side, you can just write brackets instead and put it equal to plus or minus the other side. There we are. Obviously this involves checking the answer though. So therefore we have x equal to 3 or 1. There we are. So there we are. We have our x-intercept of 3 or 1, our y-intercept of 0.7, and we have our asymptote. We do need another point because that's not enough. If you see here, we have enough to guide us here because we have a point there, and then an asymptote. So we know it's going to be going approximately, it's going to be going down like this to the asymptote. On the other side, it is going to match, of course, so we could just use symmetry and say, well, go that same distance this way, and we can get a point there. Or we can substitute. Let's substitute at this stage. So I'm substituting 4 into that definition there. Well, it's ln of 2, which is 0,7, and that confirms the symmetry story. So now we can draw our graphs. A graph, really, but it's two sections of the graph. Domain and range of f. Well, the domain is how far left, how far right it goes, the x possible values, and so it goes forever that way, forever that way. So it goes both ways, but of course we can't have it equal to 2 because that's the asymptote and the undefined aspect. So the domain, there it is there. Notice the little circle to exclude. So we have x element of R, x not equal to 2. For the range, we're going to go vertically. So we'll take this line here and we'll say, well, it's going to be y equals r. Oh, I only did it in the question that you have to do. Sorry about that. I didn't take it and make it vertical. So let's just go back to make sure. Y element of r. Well, consider this actually, while it looks if it's flattening out, it is going up forever. And this is going down forever. So straight away that means y is an element of r. If you put y element of round brackets, negative infinity, infinity, round brackets, that's fine too, but that's a waste of ink. Values of x for which f of x is less than or equal to 0. So where is this line below the line y equals 0, which is the x-axis? There we are. And notice the dots because it's all equal to. So there we are, I can describe it. From there to there, all these x values, excluding this one here. So therefore I've said from 1 to 3, including, because it's all equal to, but x not equal to 2. Values of x greater than 2 for which f of x is greater than 1. So if we have a look here, f of x has to be greater than 1, so therefore it has to be above, f of x must be above the line y equals 1. So let's draw in the line y equals 1. There's y equals 1. And that's where it's above. Note we're not taking that part because it says values of x greater than 2. So we're not looking at this half at all. We're only concentrating after the asymptote. Round circle, because it's greater than, it cannot be equal to. And we can describe those x values from that distance on, that place on, so we can estimate if necessary. I'll just solve the equation to see. There I've got exponential form, 2 plus e, which is 4,7. There we are, 4,7. I've done the equation because it doesn't say anything about using the graph to do it. It says determine the values for which that's the case. So we're using this as guidance for ourselves, but I would prefer it. I would suggest you do actually calculate that value. So there we are. From 4,7, because it's not including, circle, it's greater than, to infinity. But let's have a look at this one now. Here's exercise 6. In the textbook, page 119, once again, there we are. You can go to it if you need to. There, you can click that. Notice the hand appears, the pointing finger. But I would suggest you pause this and try it yourself before going on to the solution. What you can do is do each part in turn, then have a look at the solution as well, which might be the best thing to do. Having a look at the first part here. Here we are. Since undefined at 0, the asymptote is what? So you need to decide what makes that ln of 0. X equals minus 3. So there we are. There's our graph. X equals minus 3. There's our asymptote. Right, so sketch the graph. So we have to find the vertical, indicate the vertical asymptote. We have it. And we have to find the intercepts with the axes. Oops, sorry, I've said it twice. Intercepts with the axis, intercepts with the axes. Just emphasizing, you see. X plus 3, absolute value x plus 3 is equal to what? In order to find our x-intercept? Oh, sorry, no. This is x plus 3 giving the definition. So we're giving the definition there once again, absolute value x plus 3. So now, f of x therefore equal to, and we introduce the ln. Now that's fine. Some might think we're finding log of a negative there, but we're not really, because it depends on the value of x whether this is negative or not. And this does say for x plus 3 less than 0, which means x less than negative 3. So our y-intercept when x is 0, you need to substitute the 0 in for x. And we calculate these. This one here, of course, is going to end up being undefined because it's log of a negative number. And here, it's ln of 3, which is 1, 1, if x plus 3 is greater than or equal to 0. It means x greater than or equal to negative 3. So yes, this is the acceptable answer. So the y-intercept 1, 1. X-intercepts y equals 0. So we're going to take that and put it equal to 0. Now remember, at this stage, first thing we have to do is get rid of the ln to be able to solve for the x. So we're going to change to exponential form. Base e. So therefore, x plus 3 equal to e to the 0, which is 1. Absolute value, to get rid of it, we can just introduce the plus or minus. The plus or minus really goes on this side, but we can transfer it across that side. Solving, we get x equal to negative 2 or negative 4. And there we've already popped them up on the graph there. So once again, we have the graph. This is all right here, but our problem here you are, but our problem is on this side. We only have that point in the asymptote. We can either calculate a point, or we can use symmetry. If you do x equal to negative 6, now notice I've done that on purpose because this is 2 to the left of negative 4. That point here is 2 to the right of negative 2, which these are the matching points. So I'm just saying we could use symmetry. Clearly this is going to be 1, 1 here. Substituting x equals minus 6, we get 1, 1. There we are. And we could have found it by symmetry. I hope this isn't cut off on the at the bottom here. Notice left, right. Natty, hey? Right, let's go on to the next part. Oh, there, yes, of course, we must draw a graph. Domain and range of f. Well, domain, there we are. Remember, that's what we did. And that should help you find that x is an element of reals not equal to -3. Now this is what I talked about. We have this very fancily changing to vertical in order to be able to do it. Oops! Oh, I spoiled it by clicking too soon. There we are. And it's going forever in both directions. So therefore, y element of r. Values of x for which f of x is less than or equal to 0, which means the graph must be below the x-axis, because that's the line y equals 0. There we go. Here's the section of the graph which is below the y-axis, x-axis. And there are the values of x that make that true. So -4, -2, x not equal to 3. Values of x greater than -3 for which f of x is greater than 0,5. So there's 0,5. We actually need to do the same thing now. We need to draw a line across. Notice I'm only going from there because it says values of x greater than -3. So we need to know that value there. Open circle, unfilled because it's greater than 0,5. So let's solve it. It doesn't say solve graphically, so we better do it correctly. Change to exponential form. I'm actually just finding that value. That's why this is an equation, not that inequality. -1,35. That's pretty accurate because it's done on a calculator. And therefore x is greater than -1,35.